Let's talk about reducing fractions. Probably the most favorite topic any student has ever had to deal with. Yes, I can hear the groans even through the computer. Now, there are two different ways I'm going to show you when we're talking about reducing fractions. There's the easy way, and then there's the short way. The easy way is something that has a lot of steps, but if you follow the steps, there's very little chance that you're going to end up doing it incorrectly. So let's take a look at the easy way first. We have the fraction 14 out of 49. Now, the easy way to reduce fractions is to first do a factor tree for 14. So 14, the two factors of that are 7 and 2. And then we have 49. The factors of 49 are 7 times 7. What we're going to do is we're going to take those factors and we're going to replace it. So instead of 14, we're going to write 2 times 7. Instead of 49, we're going to write 7 times 7. Same thing, 14 is 2 times 7, 49 is 7 times 7, just written a little bit differently. Now, here's why I call this the easy way. Because we have the same number on the top and the bottom, we just cross it off. So in this case, we're left with 2 over 7. That is your reduced fraction. The other way to do this, what I call the shorter way, because it requires a lot less work, is using a fractional 1. So we have to figure out a fractional 1 is a fraction with the same number on the top and the bottom. So because we know 14 and 49 have 7 in common, we're going to reduce by 7 over 7. 14 divided by 7 is 2. 49 divided by 7 is 7. Look at that. Same fraction, got in two different ways. Let's take a look at the number 40 over 60. Two ways to reduce this, the easy way and the short way. Let's take a look at the easy way first and just kind of see what's going to happen with it. So let's take 40, do a factor tree. Well, we could go a lot of different ways, and as long as you are mathematically correct, you could end up having factor trees that look a lot different but still mean the same thing. I'm going to choose to divide by 10. 40 divided by 10 is 4. This number is not prime, so we're going to break that down even more. 2 times 2. That can't be broken down anymore but by multiplying 1 times itself. Then we have 10, which is 2 and 5. Look at that. Now let's do the same thing for 60. 60, we're going to get 10 and 6. Same thing, 2 and 5. And instead of 2 and 2, we're going to get 2 times 3. Now, the big reason kids don't do this that often is because it takes up a lot of space. But as you can see, as long as you know how to do a factor tree and get to all the prime numbers, and if you do it mathematically correctly, you'll be fine. So let's take that 40 and replace it with these numbers. 2 times 2 times 2 times 5 over 2 times 2 times 3 times 5. Now you can tell that I'm crossing those numbers off so I really don't get them mixed up. Something that can happen pretty often. Now we're going to look for similar numbers. Oh look, a 5 and a 5. Oh look, a 2 and a 2. Oh look, another 2 and a 2. Now they don't have to be directly on top of each other. If you want, you could do this. That works out okay too. We're left with a 2 on the top and a 3 on the bottom. 2/3. 40 over 60, same exact thing as 2/3. Now, if you wanted to, you could also have done it this way. 40 over 60, let's divide by something. Let's divide by 10 over 10. Let's use that fractional one. 40 divided by 10 is 4. 60 divided by 10 is 6. And if you notice, anything that ends in 0, you can just knock off the 0 and get the same thing. So you didn't even technically have to write that. You could just say 40 over 60 is the same thing as 4 over 6. And then we're going to reduce it by another thing. Well, what goes into 4 and 6? Let's think about this. We'll get a 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. and you'll get the same fraction two different ways. Now, 2 over thirds means the exact same thing. It's 40 over 60, but it's like taking a car, it's got some rust on it, repainting it. Same exact car, just looks a little bit different. Let's talk about one last one. Let's talk about 14 over 49. Now, I'm thinking we already did 14 over 49. Nope. Just kidding. Let's look at 3 over 6. Now, when you're trying to figure out what number goes into 3 and 6, you can do the factor tree if you need to. 3, 1, yeah, that doesn't really need a factor tree. 3 is a factor tree all by itself. Then we do a factor tree for 6. So for the 3, we just have 3. For the 6, we have 2 and 3. Cross those off. Oh, there's nothing left up here. When there's nothing left up top, you can always multiply by 1 and not change anything. So we're going to put a 1 in there because we're going to be left with 1/2. Just like if you had 3 over 6, and if you were to divide by the fractional 1, 3 over 3, you would end up with 3 divided by 3 is 1, 6 divided by 3 is 2, with 1/2 again.